Hello and welcome to the channel Beyond the Curve, and I'll be answering question number 4 of the 2024 May June FP1 paper. So the question says the complex number z is defined by minus 3 plus 4i. Part A, determine the modulus of z squared minus 3. So let's write that down. Z squared minus 3 is what we have to find. So first we can find what z squared is, which is going to be minus 3 plus 4i whole thing squared. So minus 3 into minus 3 will be plus 9. Minus 3 times 4 will be minus 12. Then into 2 it's going to be minus 24, and then there's the I. And then 4i whole thing squared is 16 into I squared, and I squared is minus 1. So we can write it like this. So 9 minus 24i minus 16. So 9 minus 16 will be minus 7 minus 24i. Now why the I squared is minus 1 is because we know that the square root of minus 1 is I. So if we need to find I squared, we need to square the square root of minus 1. So basically the square and the square root cancel each other off and we get minus 1. Okay, so we can now find z squared minus 3. So that's going to be minus 7 minus 24i minus 3. So this simplifies to minus 10 minus 24i. And off we find the mod z squared minus 3 and modulus of it. So this is going to be minus 10 squared plus minus 24 squared and square root of it. We don't include the I when we're finding the modulus. So we can calculate this to get 26. And that will be the answer to part A. Moving on to part B. It says express 50 over z complement in the form kz, where k is a positive integer. Okay. So 50 over z complement. Now z complement is going to be minus 3 minus 4i. We only change the sign of this middle, the sign before the complex part of the number. So minus 3 minus 4i. So therefore we could say the sign before the imaginary part of the number. So this is going to be 50 over z complement will be minus 3 minus 4i. So we need to simplify this, which means we have to rationalize our denominator. To rationalize the denominator, we need to multiply the numerator and the denominator by the complement of the complex number which is in the denominator. So this will be 50 times the complex complement of the denominator will be minus 3 plus 4i, which is again z. Denominator will be minus 3 minus 4i times minus 3 plus 4i. This simplifies to 50 times minus 3 will be minus 150. 50 times 4i will be 20i, 200i. Over minus 3 times minus 3 is plus 9, and minus 4i times plus 4i will be minus 16 times minus 1. So minus 150 plus 200i over 9 minus 16 times minus 1 will be plus 25. We can divide 150 by 25. It gives us minus 6 plus 200 divided by 25, which will give us 8. So the question is asking us to give the answer in terms of z. So we know that we have to get the answer. Our answer has to be a multiple of z. So we need to get the z out of this minus 6 plus 8i. So the common number between 8 and 6, the common factor will be 2. And if we take 2 out, we get minus 3 plus 4i. And we can see that minus 3 plus 4i is our z, which is given in the question. So this can be written as 2 times z. And that's our answer, where k is equals to 2. You can write this if you want to. And now moving on to part C. It says, hence find the value of argument of 50 over the z complement. Give your answer in radians to 3 significant figures. So we already know what 50 over z complement is, which is minus 6 plus 8i, or in other words 2z. Let's write that down. 50 over z complement is minus 6 plus 8i, and now we're told to find the argument. So the argument of a complex number is the angle from the positive real axis. So if I draw that, this is the imaginary axis of z and real axis of z. Let's say minus 6 is over here and 8 is over here. So the point will be at this part of the axis, and if I connect it to the origin, it will look like this, and we need to find this angle, which is the argument of 50 over the z complement. It's always from the positive real axis. So we can see that from the positive real axis to the positive imaginary axis, it's 90 degrees, or in radians we can say that it's pi by 2. And let's mark this angle from the positive imaginary axis to the complex number line, we can mark that as theta. So our job here is to find theta and add that with pi by 2, then we can find the argument. So let's work that out. So theta will be tan inverse, or if I have to write from the very first step, I can say tan theta is equals to opposite over adjacent. So the opposite is going to be minus 6, which is this one. The adjacent will be this, which is 8. So our theta is going to be tan inverse of minus 3 over 4 if you simplify the fraction. Make sure your cal is in the radians mode because we don't want to go wrong there. So tan inverse of minus 3 over 4 is minus 0.6435. Yes. Now we can exclude this minus because we are going to add that with pi by 2, so we need a positive angle. So we can say that argument of 50 over the z complement will be equal to pi by 2 plus 0.6435. Pi by 2 plus 0.6435, which is 2.21429 and so on. But we need to round it to 3 significant figures, which will be 2.21 radians. But since they say to find the value, it's not required for us to write radians or whichever the unit, so we can just state that it's 2.21 and maybe say to 3 SF. Now it's completely fine if this theta value is given as positive or negative. That doesn't really matter. As long as the numerical value of theta is correct, then it's alright. And we can add that with pi by 2 and find the argument. And that's it. That's the end of question number 4. If you like this video, please like and subscribe the channel, and I'll see you soon.